Wasabi, you guys. Welcome to Integration Beat Training for Intermediates Part 17. In this section, we'll be doing advanced trig substitution. So now it's not about x equals sine theta, tangent theta, or secant theta. Now we have a lot more to deal with. So let's go ahead and get right into this. So let's recall some of the basics. You've probably seen this if you remember from our beginner training. This was one of the integrals that we have. So here, I see that we have 1 minus x here, but we have a square root of x here. So in this case, the whole point is to get rid of the radical. But how can I get rid of this radical? I can let x equal sine square theta. Then dx will be sine 2 theta. So now this would be cosine theta, sine 2 theta, d theta. And then here this would be 1 minus sine theta. I'm going to abbreviate. So 1 minus sine. I can conjugate with 1 plus s, 1 plus s. So now this gives me cosine square, which cancel these out. So now I get 2 sine plus 2 sine square. This is annoying. I wish I had bounds. I really did wish I had bounds. I should have put in bounds so that I could just use Wally's trick. But here, this is 2 sine theta plus, well, this would be 1 minus cosine 2 theta now. And when we integrate this, we get negative 2 cosine theta plus theta minus a half of sine 2 theta. Yeah, that sounds about right. Okay. So now our theta is inverse of square root of x. So this is definitely negative 2, 1 minus x plus the inverse sine of square root of x minus a half. I'm just going to leave this one as inverse sine of square root of x plus c. Alright, that's our answer. What do we do here? So this looks very tricky. So I would probably need this to be tangent theta of some sort. But what should x be in order for that to happen? Let's see. Aha! Consider x equal cosine 2 theta. Let me show you why. Because I know that this is equal to 2 sine square theta, and I know this is equal to 2 cosine square theta by trig identity. So if we use this on here, right, the 2 would cancel out, but this will give us tangent square, which will get rid of the square root, and we'll have tangent theta, which will get rid of this inverse tangent. Awesome. So let x equal cosine 2 theta. Then dx is going to equal to negative 2 sine 2 theta, d theta. And now this is, well, we already see what's going on. We already saw what's going on. This whole thing is going to become theta. And now we're left with negative 2 sine 2 theta. Oh wow, look at that. This is just an integration by parts. So we get theta. I'm going to drag in all the constants so that we don't forget it. We're least likely to forget it. And so now this is cosine. Well, I mean, that's where it came from. And then we can integrate it again. this becomes a half of sine 2 theta. And so now our answer is theta cosine 2 theta minus a half sine 2 theta. And now our theta is inverse cosine x over 2. So now we have, let's see, this is our, oh wow, this whole, oh well, I mean this is x. Cosine 2 theta is x. So x over 2 inverse cosine of x minus a half of sine of 2 theta was inverse cosine of x. Oh, this would be 1 minus x squared plus c. Wow. What on earth is that T looking thing? So in the Harvard MIT math tournament, they were very evil about this. They only gave like the polynomial definition. I think it was like recursive. It was like something Tn minus 1 of Tn minus 2. Something. I forgot how it goes. I don't remember. I forgot how it goes. I don't remember the polynomial definition. But this is called Chebyshev's polynomial, and the identity, the secret, is this. This is the power of the Chebyshev polynomial. So again, if you see like a big T and they only give you like this definition, don't listen to them. Don't listen to them. It's a Chebyshev polynomial. It's a secret. This is a secret identity that they don't want to tell you because they want you to solve the problem longer. So I'm just giving you a little cheat here. Be aware of this identity. Okay. So you don't have to memorize it though. This is just, it's one of these rare things that tournaments can give you. But just letting you know, this is the identity. Alright, so if hoping we are given this, then what is this? What is something that we should do? Right? If we're given this, then what should we do in this integral? What should we do? Let x equal cosine theta. Let x equal cosine theta. The most obvious thing to do. Negative sine theta d theta. And then this will become, well, 0. This is pi over 2. Oh well, we'll use the negative to change our bounds. Pi over 2 to 0. And then we get t cos t 2023 here. So we end up getting cosine of 2023 theta. Right? But wait! We have sine theta d theta. Ah, it's one of these type of integrals. So it's a trig identity. Now sines and cosines comes from the sine law, right? Sine here, and then this is sine, cosine, cosine, sine, sine, cosine, cosine, sine. Because I'm looking at it at this direction, we might have to subtract so that we cancel this out and we get 2 of cosine sine. So this is a half though, because we only have this instead of 2. So it's a half of pi over 2, and then here we get 2023 plus 1. That's sine of 2024 theta minus 2023 minus 1. That's 2022 theta d theta. And so now this is just simply cosine. I'm gonna do this first. 2022 theta of 2022 minus cosine of 2024 theta over 2024 from 0 to pi over 2. Oh god. So, I mean, these are even, so I'm going to get pi over an integer, and this would be 1011. 1011 is an odd number, so it will be here. That's an odd pi. So that's going to be -1 minus 1 over 2024, and then minus, and then if we plug in 0, this is just I mean, it's always going to be 0 here. So I'm sorry, not 0, 1. It's always going to be 1 here. It's always going to be 1. So if we plug in 0, everything's 0, 1, 0, 0, it cancels out. Cosine of 0, cosine of 0. Oh no, it does not. I'm sorry. I'm so stupid. Cannot forget about this denominator. Ah. God damn it. Be very careful. Be very careful to how you handle your numbers. Okay. So. Oh god. Now, this and this will cancel out because of this negative sign. So now we have -1 over 2022. So this would be our answer. -1 over 2022. Oh god, this would be an annoying integral to force U-sub, right? Because you have to do a square, and then another square, and another square, and then your du is going to be a long chain. So, how do we deal with this? Well, let x equal 2 cosine 2 theta. So now, what this does, is this will, oh well, this would be an annoyance. The bounds, let's see, 2, 1 cosine, so 1 equal to cosine 2 theta. That's going to be, what would it be? What would theta need to be in order for this to be, 0. I'll use the negative sign to switch the bounds, and then plug in 0 here. In order for 0 to happen, what theta do we need? We need theta to be pi over 4. Okay. So now we have this, and then this, and then what is this? 2, and then we have 1 plus cosine 2 theta, right? And then times 4 sine 2 theta. But notice that, let me just put this at the side, sine 2 theta here, what we actually have is 2 plus, we have this root 2, and this whole thing is equal to 2 times cosine square theta. And so now we have 2 cosine theta. Whoa, mind blown, right? Because 2 times 2, we square root it, it's 2, then square root cosine square, and we get this. And now, look at this. Now we go ahead, we do it again, 1 plus cosine 2 theta. This is cosine square, no, times 2, sorry. Times, this is 2 cosine square of theta over 2, okay, over 2. So now, look at this, we created a chain. We created a chain. Sine 2 theta. So now this is going to equal 2 plus 2 cosine of theta over 2. And look at this, this can happen again, and we get 2 times, so it's 2 cosine of theta over 4, and then d theta. Now you're probably wondering, Silver, this is disgusting, because now we have 8 from 0 to pi over 4, and now we have to deal with this. Now we have sine 2 theta cosine of theta over 4. Great. Now what? Well, 1 over 4, it's just a number. It's just a number. It's just a constant. It's just a constant. It's just a constant. So, you know, lazy people like me, we're just going to use the trig identity. So, sine times cosine, that comes from the sine law. Sine a plus b, sine a minus b, we get this. And we're gonna have to add just to cancel this out. Okay. So we divide by 2, that's 4 in total. So pi over 4. We get sine of, what's 2 plus 1/4? I'm not a math Olympiad, don't judge me. 9/4. 9/4 of theta plus sine of 2 minus 1/4. That's 7/4. Is that correct? Yeah, I believe so. So, and now we get negative. This is all negative. So negative 4, 4/9 of cosine 9 over 4 theta plus 4/7. Jesus Christ. I don't know why I put that. Cosine of 7/4 theta. I put the negative at the, I just factor out the negative because I'm lazy. Okay. Oh my god, this is terrible. This is horrendous. The whole point. This is how you, that's how you solve this integral. Probably you might not get this bound. I gave myself a terrible bound. But the whole point is this is how you would approach this integral. Ooh, what do we do? Well, what's the whole point of Trig-Sub? To get rid of the square root. To get rid of the square root. That's the whole point. So, now we have 0 to pi over 2. We get cosine theta, d theta, which gets cancelled out by this. And we get 1 plus sine square theta. And now we can do 0 to pi over 2 secant square theta. This becomes secant square, tangent square. We can have 1 plus 2 tangent squares. Yeah. And so now, I'm going to go ahead and sort of factor this out. 1/2. Just for the ease. Oh, I'm sorry. That's not the right way. Wait, is it? Oh yeah, that is the right way. Yeah. So you divide 2, factor it out. Okay. And then we do u substitution, let u equal tangent theta. If we let u equal tangent theta, we get 0 to infinity of 1/2 of du of 1/2 plus u squared. And this will give us 1/2 of 1 over root 2 inverse tangent of u over root 2 to infinity to 0. And so now we have, well, 0 is just 0. Infinity is pi over 2 times 2 root 2. So I guess our answer would be pi over 4 root 2. Okay? Oh God! What in the abomination is this? So, this is actually... I actually like this integral, honestly. This is probably the coolest integral I've ever seen in Gmain. Now, this integral here, well, let me sort of edit this. This is a 6th root. Just want to let you know. This is indeed a 6th root. That is a 6th root. But there's so many cube roots here. Oh God, and there's like 2 minus x squares. And there's this x here. What is this? What is this nonsense? So, let x, I'm going to show you. Let x equal root 2 sine theta. You'll thank me later. Watch this. This is very cool, actually. Super cool. So then dx is equal to root 2 cosine theta, right? Okay. So I'm just gonna put this at the side for now. Here, this becomes 2 sine square theta. So 2 gets factored out, right? I'm just gonna put this 2 sine theta here. Well, I should probably abbreviate. Let me abbreviate everything, actually. So cosine, we have the cube root, we have square root of 2 sine theta, plus, and then we factor out the square root of 2. This is cube root. This is a cube root. And then here, this becomes 1 minus sine square, so it's cosine here now. Okay. And now we have a 6th root that we're dealing with. We have root 2 sine, and then again 2 minus 2, oh well, this is 2, and then 1 minus sine square as cosine. Okay, and then here we have cube root of 1 minus 2 square. Oh, what does this equal? Root 2 cosine. If we can actually simplify this. This is, well, we can factor cube root square. This is root 6, or yeah, this is root 6. Root 6 over 2, and then we have a cube root of s plus c, and then here we have a 6th root of what appears to be 1 minus 2sc all over. Here, this seems to be what? This seems to be 2 sine square. This looks like cosine 2 theta. Right? That's what that is. So we're gonna keep simplifying. Don't you worry. Don't you worry. This 1 minus 2, this is cube root of what? If you remember from our 1 minus or 1 plus sine 2x trick, this is s, or I'm sorry, let's do c minus s because it's squared. So we can choose whatever we want. So, and then so now this becomes this, and then we can utilize these two here to cancel out this, because cosine square minus sine square is cosine 2 theta. They cancel out. Holy mackerel. And what is this? We're left with this. And then here we have root 2, well, 2½ plus 1 over 6 of cosine theta, which equals sine theta. Sine theta is equal to x over root 2. Wait, what? What? Would you look at this? Would you look at this? This is x. root 2 just is minus a half. This cancels out. So we get root 6 of 2x plus c. Yes. Yes. This whole function. This whole function is just a constant. This whole function is just a constant. This whole function is equal to 2 to the power of 1 over 6. I don't know how the hell they found this function, but I mean it's India, but like, look at this. This is freaking cool. This whole integral equals to just this, just a constant. Just by this trig manipulation, this Trig-Sub just cancels out everything. The power of trig identities is awesome. Very cool. I bet you were not expecting that. Now let's kind of relax a little bit. So here, what do? Well, this is where, in most use substitutions we learn to experiment. We can do the same thing for trig substitution. What if we let x equal tangent theta? Right? We're not going to jump in with dx yet. I just want to see if this works. Let's see, we get secant square. We get secant square theta. Let's see, tangent theta. See, this cancels out. Oh, this is sine 2 theta. This cancels out with inverse sine. Oh, this works. Awesome. We're going to use it. So now, then dx is equal to secant square theta d theta. We already know this is going to turn out to be 2 theta. And then we're left off with secant square theta d theta. And then for 0, it's 0. For 1, it's pi over 4. Okay, so now we do integration by parts. Secant square is tangent. Tangent becomes ln of secant theta. So now we have 2 theta tangent theta minus 2 ln of secant theta. And we're plugging all of this. Pi over 4. 0 is just 0. Pi over 4, we get 1. Pi over 2 minus, and then pi over 4 here is 2 ln, I think that's square root of 2. And that is our answer. This looks weird. This looks very weird. What do we do here? I see that we have 1 minus x, 1 plus x. The best way to get rid of the radical like this is to use x equals cosine 2 theta. Then dx is equal to negative 2 sine 2 theta. Alright, let's use it. So then our bounds, see 1 is here, so I would need 0. I'll use the negative to switch the bounds. If I need negative 1, in order to have negative 1, I need what? Pi. So this would need to be pi over 2. Alright. Delete my reference. Okay. So then 1 plus cosine 2 theta, that's going to be square root of cosine theta. Oh, don't forget that we have 2 times sine 2 theta as our d theta. And then we have root 2 plus, then 1 minus cosine 2 theta, that's 2 sine square. So we will have root 2 sine theta. These root 2 cancels out. So from 0 to pi over 2, we're left off with 2 sine 2 theta cosine theta 1 plus sine theta. We could honestly just abbreviate all of this. That's what I'm thinking about. You can literally just abbreviate all of this. So we have 4. We'll put 4 so that we can bring out our sine theta cosine square 1 plus sine theta. Oh, we can use cosine square into 1 minus sine theta, 1 plus sine theta to cancel this out, right? So now we have 1 minus s. Oh, thank goodness. Thank goodness. Look at this. This is sine minus sine square pi over 2. I don't know about you, but I'm going to be using Wally's product. So here for sine, I think that's just, let's see. For sine of x, this becomes negative 4 cosine theta for 0 to pi over 2. This goes 0. Plug in 0. This is 1. So this is going to equal to 4. And then minus sine square. This is pi over 4 times 4. That's pi. Oh, wow. So this integral is equal to 4 minus pi. That looks horrendous. But let's just check. Let's see. Oh, I can already see this. Do you guys see it too, right? Do you guys see the trick to this? Let x equal cosine theta. Because then this is going to be sine 2 theta, and this is going to be cosine 2 theta. So now, I already know how this is going to go. This is going to become tangent 2 theta, so it's going to be 2 theta. And then our sine theta d theta, I think we might need the negative to use to switch the bounds. 1, well, this is going to be 0. And root 3 over 2. Root 3 over 2 that equals cosine theta. What would that be? Root 3 over 2. So cosine is this. Aha. This is the long range, so it needs to be pi over 6. Okay. So now, this is a simple integral, integration by parts, right? And then sine, negative sine, negative sine. I'm sorry, sine, negative cosine, sine, negative sine. Here, this is 2 sine theta minus 2 theta cosine theta from 0 to pi over 6. Plug in 0, everything's going to be 0 because of this theta and the sine theta. Pi over 6. Pi over 6 is here, so that's a half. This is 1 minus, and then we have pi over 3. Then what's cosine? Root 3 over 2. So our answer is pi over 2 root 3. A bunch of one of these. So let x equal sine theta. Let's just see what happens. Let's see. We get dx cosine theta. Behind me, we get, let's see. This is pi over 2. Negative pi over 2. We get cosine. Let's abbreviate, because there's a lot happening here. So cosine minus sine here. I have cosine here, so that's going to cancel out. And then I have 1 plus sine cosine. Oh, do you remember this? I really hope you remember this. It's the 1 plus sine 2x trick. So, 2, negative pi over 2, pi over 2. We have 2, we plug in 2 here. We get sine 2x, sine 2 theta technically. Aha. And now this is what? What is this? Oh, I'm sorry. There you go. That's how it's supposed to be. So now, this is let u equal sine plus cosine, right? 1 plus u squared du. Plug in pi over 2 here, we get 1. Plug in pi over 2 here, we get -1. Okay. So now we have 4, just for symmetry's sakes. So now this is inverse tangent of 1, which equals pi over 4. But we have 4 here. So this whole integral just equals to pi. So it's just pi. So that was our last integral. And advanced trig-sub. It can be very scary sometimes, but again, it's just like the force u sub. You just gotta experiment with your substitutions. So I hope that was very helpful. This is very useful actually, to get rid of disgusting radicals. So but other than that, know your trig identities. Thank you so much for watching, and I'll see you guys in the next part.